Hello everyone. Today we're going to be discussing the discoveries that we gained through the analysis of Glassdoor job data from 2017 to 2018. The dataset focuses primarily on the tech industry and includes information on job titles, salaries, locations, and more. Contributors include Jingyao Gong, Sheena Knott, and Alex Larson. To guide our understanding of what is being shown on the screen, we're going to cover assumptions first, and then we're going to go into how we clean the data and the challenges that we faced whenever we cleaned it. Then we'll proceed into understanding what it was that the data is telling us, and then we'll show our decision tree model and evaluate whether or not this data was appropriate for our questions or inferences. Here are the questions and assumptions that guided our analysis of the Glassdoor data. The features we removed included salary range because it was in multicollinearity with annual salary. With job type, although we did conduct some analysis on this feature, it did not have many categories and was left unused to train the model. Seniority has too many not applicable entries to be applicable to our analysis. Here in these box plots, we see that the outliers for company rating, annual salary, and company age. The outliers within company rating are acceptable because it's within a 0 to 5 system. There are no outliers, implying that the samples are evenly distributed within the company size column. Annual salary has some extreme outliers, but these are to be expected. Company age outliers. Interestingly enough, the outliers to the company age are going to be older companies that ended up having hired in that are developing a tech sector. Whereas the median or the mean that we'll see in the next slide indicate that most tech companies that are hiring on average 50 years old, but the median is 28. The mean size of companies that have postings is 2,574, and with the median being higher, it can be inferred that smaller companies are not hiring as frequently. This distro plot shows the frequency of salaries offered on job postings. The most frequent offering of 81K answers the question of what a job seeker can expect. And here is a plot of the job sectors and how frequently they appear within the data. Information technology has the most postings within this data set, and it can be inferred that our above median job has a high probability of being derived from there. Representation doesn't necessarily mean you will make above median, as we can see with Excel being the most frequently required, yet the average is barely above our median mark. And as shown before in the previous slide, the industries requiring the most programming language, application knowledge, is in the information technology sector. This is true for all columns, be it Rust, Spark, AWS, so forth. Here we have a visual of why the job type column was removed, with the second most frequent job being not applicable in biotech, though it could mean that there was not the job option in the template of the web app. Data scientist, and that's right, you guessed it, information technology might be the career path for the above median worker. So if we look here at this pie chart, which is a salary distribution by region, uh, we can see that the West has the lion's share of the salary distribution. Um, this doesn't necessarily mean that you're going to make more money at any job that you apply for in the West. What this means is that there is a high likelihood that you will be making more than you would elsewhere. Um, and this kind of bears out with, considering that California, Silicon Valley, a lot of Microsoft is based out of Washington, I believe, and so then you look over at the Northeast, and you have areas like New York, and Delaware, which are very large areas for tech. Browsing through the correlation matrix here, you can see that there are a few features that actually do correlate, one of them being company age and company size. And this makes sense because as a company gets older, if it's profitable at least, then you know it would need more employees to uh, basically help with that growth. Another correlation is between annual salary and Python. And this is kind of a start to answering our question of what do we need to know to make above median. And then you can see a correlation between Python and Spark, which simply just means that if there are, if a company is requiring that you know Spark or Python, then it's probably going to require you to know the other. That being said, you can see that with a few of the languages. As a matter of fact, with AWS and Spark, as another is another mild positive correlation, and between Python and AWS has a very very light correlation. So now that we've gained some understanding from the data, we have an idea of what correlates. We need to prepare the data for modeling. The decision tree model requires all your columns to be numeric. So where before uh, we were able to have like categories, for instance, like job region, uh, you have to replace those regions with values, and so uh, if you just look at the nation and start go from the northeast and that be your 1 o'clock, you can just go 1, 2, 3, 4, 5, and start circling back to the Midwest. It should also be noted that scaling was unnecessary, because it actually provided no difference whenever we ran the model with standard scaling, min-max scaling. Um, and so that being said, we trained the data on 30%, and it gave us an accuracy of 66%, 66% if we're being generous, which will pass you in college but fail you in high school. So with a depth of 7 and 30% of the data set being our training set, uh, we come out with Python being plotted at the very top to establish our pay above median. Um, this is not the same as importance. It's actually different. It simply means that there are 483 samples before it's split to above and below median. So so what is rather interesting is that competitors will, if a company does not have competitors, um, more often than not, they'll be more than happy to pay you below median for the same job in another field. Uh, and job region, as we discussed earlier, and as you can see from the pie chart before, the West had 23.6% of the salary distribution. That is not unexpected. And so, if you'll harken back to the decision tree, um, noticing that Python is on the very top, plotted at the very top, um, it's fair to say that it would be quite a large factor. However, the most important factor that was found was company age. And this is the most important factor that would determine whether or not you were able to earn above salary. I mean, excuse me, above median annual salary for employment. So, well, we can finally come to the conclusion that you need to live in the Western United States, know Python, and look for any company that is younger than 86 years old. Uh, and this should be fairly easy because the only tech company, or rather the oldest tech company, is IBM, and it was founded in 1911. But the other five, or what are considered the five tech giants, are Google, Amazon, Apple, Meta, and Microsoft. And none of those are older than 86. None of those are older than 40. Yes. But anyways, uh, thank you very much for your time. And this has been our analysis of the Glassdoor data from 2017 to 2018.